so that's the first module, just kind of the brief introduction of what is Asterisk and where does it fit in the world. I hope you understand that Asterisk is more than just a PBX, but it can be used in a lot of different ways. The name Asterisk was chosen because it really is kind of a wild card. Anybody use the asterisk character in Linux to glob a whole bunch of files? Well, Asterisk was given that name because it is kind of a wild card. It matches on all kinds of different things. It is open source software. For the open source zealots in the room, it is a dual license. There's both a GPL license, or you could get a commercial license from Digium. Digium's done it that way so that they can offer commercial offerings as well as the open source version. And again, lots of different ways to configure Asterisk. Okay, another question here.
Okay, please explain to me how Asterisk is more than just a phone system, more than a PBX.
Because of some of the scripting things we're going to get into, it really becomes more of a voice application platform for building voice applications than just a PBX that routes calls. Let me give you an example.
For example, I think of my PBX system. I've got a typical customer who just has a SIP phone.
Mm-hmm.
And thank you for calling foobar.com. You have reached.
Mm-hmm.
If you know your party's extension, press 1.
Right. And let me give you a couple examples that might kind of set the stage for what we're going to talk about a little bit later today. Imagine that company that you're setting up this PBX for wants to be able to route sales calls to different sales agents. And maybe they have somebody that's working the East Coast and somebody that's working the West Coast and somebody that's working the Midwest. Imagine as calls come in, being able to look up that customer's customer number in a database and say, oh yeah, he's in the Midwest, but he used to be have George as a sales agent, so we're going to route the call to George instead because we know that there's that relationship already established.
Right, but how is that different than just
Most PBXs that you get on the market, that's very, very expensive and very, very difficult to code those sorts of things into them.
The other thing that I would say is when you have the applications like a VoIP gateway, that is not a part of a normal PBX.
Right.
That's normally
that's another. That's right. Whether it's a signaling gateway, whether it's a voicemail server, whether it's a audio conference server, a lot of these things are typically done as independent boxes, and another vendor will sell you 5 or 6 different pieces that hopefully talk together to do that. Where Asterisk, you can run Asterisk on a processor as small as one of these little gum sticks processors, or a little teeny tiny embedded processor, all the way up to running it on some very, very large scale hardware. A typical PBX won't scale down to run on an access point or a gum sticks processor, and won't scale up to run on a mainframe. So you get lots of flexibility and scale there as well. All right, any other questions? All right, let's move on. The next thing we want to talk about is kind of the architecture behind Asterisk. We want to talk about some of the major components, the structures within Asterisk. Talk about some of the user interfaces, both interfaces that you as an end user might use, as well as some programmatic interfaces that other programs can use to interact with an Asterisk system. I'll talk about where does Asterisk stick its files within the Linux file system. I'll talk a little bit about the configuration methods for configuring Asterisk, and then talk about kind of the 5 most important configuration files. We're going to start to dive into the configuration files and understand them a little bit more. First of all, from a purely architectural standpoint, remember that Asterisk starts out as just being software. And that software is going to run primarily on Linux, but you can run it on BSD, or you can run it on Solaris, or you can even run it on OS X if you want to. Anything that's a Unix-based operating system. Some of the hardware drivers, though, were for, say, the analog cards or the T1 cards, those sorts of things, were created for Linux. And so they often don't have equivalent drivers, or the drivers aren't quite up to speed in some of these other operating systems. So if you're not sure, well, should I deploy it on BSD? Should I deploy it on Solaris? Should I deploy it on Linux? If you're unsure, go pick your favorite Linux distribution and deploy it on your favorite version of Linux. Okay. Now, if you don't get anything else, oh, we have a question over here.
Okay, you're talking about
Mm-hmm.
But
Really, if you're comfortable with building your own Linux distribution and running on that, run it on whatever you're comfortable with. If you want a supported operating system that you can go to somebody and get support on when you need help, then go buy a Red Hat or a
like a distribute, but I would really be more. I'm more of a FreeBSD guy.
okay.
So
So run it on FreeBSD if that's what you're comfortable with.
this operating system or this application.
Sorry, what's that? Sure.
Did I like skip? I'm sorry if I. Yeah, I'm in question and answer, and that's sorry.
That's all right. We'll make sure we leave plenty of time for questions and answers.
It's just that when you said that, I'm just like, well, wait a minute, hold on a second, because I'm thinking of the way Asterisk is deployed. It's very specific to the operating system, and you were just saying
It's not that specific to the operating system. It runs just fine on BSD. It runs just fine on Solaris. It runs even on OS 10. It runs just fine. It doesn't run well in Windows. Yes. There it's running right there on an Apple box. How about that? Yes. Yes. It'll run just fine. Okay? The more important thing that I want you to understand is this picture right here. Okay? This picture kind of sets out the map for the architecture of how the different pieces of Asterisk work together. Okay? Across the top, we have some blue boxes. Across the top of this picture, I have what we call channel drivers. Channel drivers are pieces of Asterisk that go out and talk to the outside world using a particular protocol. So you see I've got a SIP channel driver up there, for example. That's the piece of Asterisk that talks SIP to the outside world and converts that into something that the core of Asterisk can understand. We've got a channel driver up there called DOTI. DOTI is the Digium Asterisk Hardware Device Interface. Nice name. That's what talks to analog cards, T1 cards, kind of traditional telephony cards. The other channel drivers up there, EEX2 and H323, those are other voice over IP protocols that Asterisk knows how to talk. Across the bottom of this picture, we have what we call drivers and converters. These are tools that Asterisk uses to either write out some kind of records. And so like our CDR drivers are call detail records. That's how it writes out a log of what calls have been made on the system, by who, and how long did they last, those sorts of things. There's drivers for different audio and video, what we call codecs. These are the mathematical algorithms for shrinking down the audio or the video so it takes up less bandwidth. There's file format drivers that knows how to read files from disk, write files out to disk. And then there's system configuration drivers. Drivers for saying, hey, how am I configured? What SIP devices am I supposed to talk to? What analog devices am I supposed to talk to? Those sorts of things. Those all feed into what we call the core of Asterisk. The core takes care of loading the other modules, taking care of talking to the channel drivers. And the biggest piece of the core is something we call the dial plan. The dial plan is really the scripting engine within Asterisk. It's where you put all your logic in the system. It's where you say, hey, if somebody dials extension 123, what's going to happen? Okay. Now, on a traditional PBX, that's just a simple routing table, right? It's like, well, 123 goes here, and 124 goes here, and 125 goes there. In Asterisk, it really is more of a scripting engine. If you dial extension 123, you can say, well, check the internet and check the stock price of Red Hat. And if Red Hat's over $40 a share, and the temperature outside is above 32 degrees, then I want to route the call this way. Otherwise, route the call this other way, or stick them in a call queue, or place them on hold indefinitely. Whatever the case may be, you have all the logic to be able to script that any way you want. So it's much more free form than a traditional PBX. Now, the dial plan there calls on a couple of different things. It calls on applications and resources. Applications are things that happen sequentially during a call. So it's like answer the ringing line, play this sound prompt, start recording the call, play this IVR menu, send the caller to voicemail, hang up the call. Those sorts of things. Those are applications. And we'll get into some sample applications here in a few minutes. The dial plan also, like I said, calls on resources. Resources are things that are used asynchronously, not just sequentially one after the other, but in the middle of a call. Things like putting a call on hold, or putting a call on into a parking lot, or playing hold music, or call transfers. These sorts of things that happen in the middle of a call use resources within the Asterisk system. Last but not least, I've got the two yellow boxes there that I want to highlight there in the core. The one on the left is a command line interface. So anybody who's familiar with Unix or Linux knows we have to have a command line interface for the administrator to go in and see what's going on and watch the calls that are flowing by and those sorts of things. We also have a programmatic interface called the Asterisk Manager interface, or AMI, shown over there on the right-hand side. This is an API that external programs can use to interact with Asterisk and say, hey, Asterisk, what calls are going on the system? Or, hey, Asterisk, call Jamie, and when he answers the call, play this prank sound file. Tell him his phone system's been eaten by iguanas or something like that. Whatever you want to do. It's an external API that external programs can talk to Asterisk and kind of do command and control of an Asterisk system, which is very, very friendly. I wish every PBX out there had those sorts of things. But that's kind of the big picture of the architecture of Asterisk. It's a set of these different modules that you can load up and use in various ways to drive whatever it is you're trying to build out of the PBX, whether it's a phone system or a VoIP gateway or a call center application, whatever it is you're building, you're going to mix and match these modules to talk in various different ways. Okay, let's talk in a little more depth in each of the pieces of this picture, and then we'll come back and start diving into the configuration. First of all, like I said, the core is kind of the heart of Asterisk. It loads up all the other modules. It provides timing. It reads the configuration files. It's what takes care of processing the calls, answering the call, playing back sound files, hanging up the calls, those sorts of things, and then converting the different protocols so that they can talk with each other. Okay, so it's really the heart of the system. Now, like I said, everything else in Asterisk is just loadable modules. So the channel drivers are all modules. The file format drivers are all modules. The CDR drivers are all modules. Everything else is a module. And each of these modules might provide a channel driver or an application or a resource or a combination of those. And you as the Asterisk administrator get to choose which modules get loaded up. By default, Asterisk is going to load up all the modules it can find. So again, it's 150-something different modules last time I checked. Okay? If you're building a very specific, Asterisk system for like a very niche market, you may only need 5 or 6 of those modules. Let's say you're building an Asterisk system that fits on a little embedded PC that lives inside some sort of embedded environment. Let's say you're putting it on a ship out in the middle of the sea, and you just want these two systems to be able to talk to each other, and Asterisk is just converting between a couple of different formats so that two disparate systems can communicate with each other. Maybe you've got a telephone system and a radio system, and you want them to talk to each other. You may only need 5 or 10 modules to get that particular piece working. You may not need things like voicemail and auto attendance and conference calling. Does that make sense? So you as the administrator get to choose what is it that I'm trying to accomplish with this system. Okay. Now, let's talk a little bit more about the configuration. By default, Asterisk gets all its configuration from a set of just plain text files. Okay. Now, you can augment that with something we call ARA, or the Asterisk real-time architecture, where instead of looking at text files, Asterisk is going out and querying, say, a relational database or an LDAP directory or some other structure out there across the network to say, hey, what do I do next? Hey, what configuration should I have? This comes into play, especially if you've, say, got a large number of Asterisk systems and you want to have sort of a centralized configuration for all those different systems. That's really